Now today, let's look at the case 2 scenario. The case 2 scenario. Case 2 scenario means that there is a buffer system. Okay, a buffer system will be where you have a weak acid plus its conjugate base, or a weak base plus its conjugate acid. So these are the criteria to have a buffer to be fulfilled. Okay, you need to have either a weak acid and its conjugate base, or a weak base and its conjugate acid. And so there must be a conjugate acid base pair. So with a buffer, there will always be an acid system and a basic system. Okay, so a buffer will help to resist a change in pH because one side will be an acid, the other side will be a base. So it will help to remove away any excess acid or base added. Okay, another example, this is a base, this is an acid. Okay, so there are two ways to make a buffer solution. Okay, you can either add both the weak acid and its conjugate base at the start. So for example, over here you have your weak acid and you have your conjugate base added. So over here you have both your acid as well as your conjugate base. So therefore it will form a buffer system directly. Another way to form a buffer system is to have an excess of the weak acid and then a limited amount of strong base. So for example, okay, let's do an ICE table for this. If I calculate the moles, this is 0.001, this is 0.002, 0.001. Okay, your NaOH is limiting, so it'll be completely used up. End result is you will find that you have, at the end, you have both the weak acid as well as its conjugate base left over. So this will result in a buffering system as well. So either of these scenarios will lead to a buffer system being formed. Now, how do we solve questions for buffer? First of all, identify the buffer system. In this case, a buffer system is your CH3COH and your CH3CO-. And in the buffer system, identify which one is the acid and which one is the base. Once you have identified that, you just use this equation, the modified Henderson-Hasselbalch equation, which I teach my students. pH equals to pKa plus log base over acid. Now with this equation, you no longer have to care whether it's an acidic buffer or basic buffer. This equation will apply all the time. Okay, so once you have found this, just put in the concentration. This is 0.3. 0.3. This will be 0.2 as given in the question, 0.2 and 0.3 respectively. Okay, Ka is given as well. Sub this into your pKa. Put that all into a calculator. You get 4.92 as your pH of your buffer. So this 1 minute of chemistry, I'll see you the next time.